Next up on our list of kinematic concepts of motion is speed and velocity. Now these are very similar to one another, but in the same way that distance and displacement are different, speed is different than velocity. So speed is what you would imagine. Speed, if we want to calculate that, is equal to going some distance in some amount of time, distance per time. Now, speed can be 10 miles per hour, and the speed is the same whether you're going 10 miles per hour to the right or 10 miles an hour to the left. Those are the same speed, but different velocities. So velocity is going to be speed with direction. And again, this is a vector quantity that we were talking about before. Now we usually identify that as, if we have a ball or some object that's moving, it has some speed, and then the velocity is showing the direction of that speed. Velocity describes how position changes relative to time. So if your position changes, meaning you're not in the same spot sometime later, then you must have some speed or velocity to change your position. Here's an example. If I go 60 miles and it takes me 1 hour to do that, then my speed is 60 miles per hour. We usually abbreviate this unit as miles per hour, like so. The standard unit for speed and velocity is going to be what we're going to call a meter per second. This is abbreviated M over S. Another example. So if speed is 0, let's put a unit on there, meters per second, then the distance over the time is also 0, because that's what the definition is. For this to be 0, that means the distance that you went is 0. That makes sense. That should be logical, because if your speed is 0, you're not moving. This is also referred to as at rest. If you are at rest, you cover no distance because your speed is 0. Let's do some examples of that. So again, with the same kind of simple examples in one dimension. If here's my position, a one-dimensional axis, x in meters, and this is 0, 1, 2, 3, 4, 5 meters in a line. If at time 0, meaning we just are starting our time is 0 seconds, we are at this position of 1. If some time later, right, this is at position 1, at time 1 second, or we started our stopwatch and it was 1 second later, and we are at a position of 3 meters at that time, that means we must have had some velocity because we moved. Let's do another one. Time equals 2 seconds. So another second later after this time, if you're at 5 meters, we can describe that as, or say it in words as, this object, or this ball, whatever we're talking about, is moving from left to right. Now, by this coordinate system that I've defined here, where we said x is in the positive direction, it gets larger, then it's moving in the positive direction. Let's go back to our definition of velocity and speed. I'm going to start calling speed v as a symbol, velocity is going to be more specific. It's going to be displacement over time. Now remember, displacement and distance can be the same, but are not always the same. This is going to be, remember our symbolism, the change in position over the time that's gone by, which would be the change in time. The change in anything is that thing final minus that thing initial. Final position minus the initial position. The same goes for time. The time final minus the time initial. And we can calculate this. So let's do this from a time change of 0 seconds to 1 second. So from here to here. The final position is 3 meters. The initial position was at 1 meter. The final time was 1 second on our watch. And the initial time was 0 seconds on our watch. A lot of the time you can start time whenever you want, so maybe you won't see this change here. It'll just be over t. Well, let's calculate this. 3 minus 1 is 2 meters. 1 minus 0 is 1 second. So our velocity must have been 2 meters per second. Now we figured that out from this point to this point. But we can figure it out from this point to this point. So let's do it one more time. The final position minus the initial position, but now we're going to do it for, this is our initial, this is our final. Our final position is at 5 meters. Our initial position was at 1 meter. Our final time was 2 seconds, and our initial time was 0 seconds. So this is 5 minus 1 is 4 meters per 2 seconds. 4 divided by 2 is 2. And we keep our unit, meters per second. So we get the same answer. So it doesn't matter if we did it over this time step or this time step or the total time step. You should get the same answer if this thing is moving at some constant velocity. Moving on to the next concept. This is going to be one step deeper in how things change. So we did distance or position of something. That's where it's at. We did velocity, which was this thing changing over time. So acceleration is going to be the next thing. Acceleration is how velocity changes relative to time. Okay? So here's an example, a very simple example. If velocity doesn't change, we can, in other words, say that it is constant or constant velocity, then acceleration must be 0, because acceleration is how velocity changes. If it doesn't changes, then that change is 0. So here's an object moving to the right with a velocity of 1 meter per second. Sometime later it's over here, still moving 1 meter per second. In this case, the acceleration, which I'll give the symbol A, is 0. Now we'll talk about units for this in a second. Acceleration, here's the definition. A is going to be the change in velocity over the change in time. Symbolically, acceleration is delta or triangle change in v over change in t. And that's the definition of acceleration. Let's do an example. Let's say we're sitting at a stoplight. At rest, which means our velocity is 0. meters per second. The light turns green. We hit the gas and we start to go, and after 2 seconds we look down at our speedometer and we're going 2 meters per second. After that time, our speed changed. So we must have, from 0 to 2, so we must have accelerated. Let's calculate it. Our acceleration is the change in velocity over the change in time, which is the final velocity minus the initial velocity. That's the change in velocity. The change in time is the final time minus the initial time. The final velocity is what we're going at the end, 2 meters per second. The initial velocity was 0 meters per second. The initial final time, this all happened in 2 seconds. The initial time, we started our stopwatch at the beginning, which is 0 seconds. And so we have 2 meters per second divided by 2 seconds. 2 divided by 2 is 1, but unit-wise, we have meters per second per second. This is often written meters per second squared because there's 2 seconds in the denominator. It basically means that after every second you're going this many meters per second faster. For this particular example, if acceleration stays the same, every second the car is going 1 meter per second faster. In summary, we talked about vectors. This means that there's a value plus a direction. So this is different than this, even though the length of the arrow is the same. The length of the arrow symbolizes the magnitude, or how much. We talked about a coordinate system. Basically, we need to say where position is 0 and which direction is positive in any direction. In a three-dimensional system, there would be another axis coming up towards you out of your screen. We also talked about distance and displacement. Displacement is the change in position, which is the final position minus the initial position. Velocity is the change in position over time. So velocity equals the change in position over how much time goes by. And then lastly, acceleration is defined as the change in velocity, if it happens to change, over how much time goes by.